Hello to part 2 of my tutorial. This time I want to continue with the rest of the packet header and then continue on with the payload. And we stopped so far at the message type. We read the header flags and then we figured out that we also have to bit swap these values. So this 20-bit value is a little bit tricky to read. And so I will start with that. Reading the header flags should be fine because bitwise it's the same order, NDNS. But message ID we will read as a 16-bit value and swap it, and then or the top part on top of it. So let's do that. So essentially we take the upper 4 bits, shift them 16 bits to the left, and then insert the other swap bits to make the whole number, and then apply this as the actual message ID. So just to make sure this works, let's actually display that as well. Oh, it's called message ID, right? Yeah. Oh, actually first header flags. Okay, so actually display it in the tree. Okay, let's see if I made a mistake. Seems I do. Okay. Message ID. Which one is it? 912. So I think I will cut a lot in this video so you don't have to watch me find stuff. I can just show you the result. So tree maker line 12 message ID. because I wrote it lowercase here. Okay. Just to make it similar everywhere. Let's try that again. Naming is important. So no flags. Okay, we should have flags here. That is correct. Oh no, that's a message type. No header flags actually. Okay. So message ID goes up. Request, response, and yeah, message ID. So we should also add the case that there is, also, if I click on this, okay, it shows me the actual byte involved. Oh, that is nice. Let's see. I can also get the extended payload size if it's available. We need a new field for that. Oh yeah, it should be named payload size extended. Still out of the header. Okay. Now actually use it. Okay, but I don't think I have seen a package that uses this recording. Let's see. Oh, and we have a problem. 31. Because I missed the comma. Okay. Yeah, it doesn't look like we get an extended packet. Let's check this longest one. Yeah, even that's not extended. Okay. These values actually mean something, so let's decode them and write some readable text here before we get to the payload. First off, we need more constants. So these are all the fields. Const message type. So I don't know everything, so can I have? Well, let's see if I can do this in Lua. Let me Lua. And then okay, just that. Okay. quite sure if I can do this, but let's try it out. Oh wait, other way around. Oh, let's see if this is valid lure. Test it. Okay, I will cut this out. Let me look this up. Okay, just put it in brackets. That's easy. Okay, is this about that? Okay, that is fine. So next we want to make the field for it of type string instead of hex. So we make want to get the actual message type out. So this you can already right shift it 4 bits because it's the upper nibble essentially that's important here. If we utils here, so it's a key is contained. We will add this, otherwise we will say it's unknown. So let's see, that's how we concatenate strings. Lure and still outputs a number. Otherwise, we just say it's unknown. Okay, let's see if all that worked. So we changed the field type, we changed how it's processed. We make us 13. Oh, then. Okay, what else? 24. Oh, we're looking for an end. Problem. And there it is. Message type is unknown. This is not working. Oh, because they are not strings. Yeah. Okay, how about now? Message. Okay, so message type message. Reply. Okay. Sync at the end. We also have other types. Notification. Okay, great, that works. No extended payload size to work with currently. But if we had to, let's just see how the others do it. So the details that I want to do next. TDF, it's just a generic function. Who reads the packet here? Okay, I will cut this. Okay, fireframe. So the payload size is read already, and the additional data is just added onto it. I think this is wrong. This should be left shifted, otherwise it's overriding it. Yeah, it's just wrong in the same way. So this should be 1, lowercase. Yeah, because I already have it a half byte. I don't need to check it this way. This is confusing. This should be shifted atop. Okay, so probably this just never happens, and so it hasn't anyone noticed yet. But I think I have to make a pull request here. Okay, never mind. So in my code, I will read this extended thing and read packet. Okay. Now we have to actually read the payload. The question is if there are enough bytes left. Now let's try our log function out for that. Yeah. So it actually calculates the payload size. So this would make at least sense to me because then you have a 32-bit value with these two together. So this size should match the remaining buffer. Okay, let's see what we get. Yes, it's good. So not saying. It's not even getting there. Wait a second. Place print, right. Read packet. Do this here. I mean, this has to either print this or that, so why it's not printing anything? It should be empty. Okay. Okay, something goes wrong there, I assume. I can, of course, does not see this way. Okay, then. Okay, Noah, how do you find the length of a string? A hashtag, okay. No problem. It matches. Okay. I love it when assumption turn out to be true. So as far as I know, the rest of the package should be just these tags. So it's just a big list of tags that could have nested tags below them. So it would be nice to add these to the tree now. And these can have different types, so this could take a little bit longer. I'm not sure. Well, let's just try to read one TDF and then bail out. Also, I have to keep track of the remaining bytes. So the current position would be 12 with a normal header. And it would be 14 if later. And now and as usual, we just make it an empty object that we will fill. So while actually I don't even need to know the position. Then just ignore that because I have the stream with the remaining data. So I just use set size to try figure out if I can still read something. Okay, just in case. While condition do end. Condition to, and I want to instantly break it because I just want to pass one for now. I will make an extra class or module for this because this will be a bit more complex. So let's get in the file. Blaze defined fields. Okay. Fields. Oh yeah, before I start with that, I need to load the thing. Okay, I didn't finish with the labels of the remaining header stuff. So let's fill that out. Error codes, so header flags, message ID, that's fine, that's anonymous. These two are actually strings. So the component is kind of easy. Because those are known. So more definitions. These dictionaries are pretty handy. So Probably have to write them one by one. So now get the numbers right. Okay, I guess redirector is just 5. Let's see if that's allowed syntax for Mandua. It's a hexadecimal value, but I'm not sure. Okay, this is valid. Okay, this. So that is a problem for the tree maker. This time it's a component name. Okay, now with the magic of code, we should see the names. Okay, something crashed, that's not good. Okay, I don't know why. Okay, but reliable. So what's our log saying? Okay, I think he has an issue with that, so let's just translate this. Okay, how about now? Okay, still bad. So how about that I cannot have an empty variable? Something like that, imagine. Sure. Okay, that probably needs to know a type. Let's see. Nope. Okay, so what's the problem here? I will cut this and come back to you. Okay, that was easy. I just had the wrong field type. I also have to change this to string. So that's why it's important to define the right types in Wireshark. Also, now I want to know, can I just have hex values? In a dictionary. That's good. Util authentication, user sessions. Yeah, that looks good. So the same for the command now is a little bit more tricky because every component has its own commands. So I have to essentially make a dictionary in a dictionary for each entry. But let's see if I can get this together for at least, let's say, util or something that is used a lot. Util here. Because it's dependent on the component, I can essentially copy that. Difference that this will change. So authentication, we get its numbers in here. And yeah, actually no, we want to do util, that is number 9. And all functions of util. So we have find this faster. Util component. Okay, these are all the commands. So now let's transform this text. there we have it. Just transformed for use in Lua. Okay. That's nice. So TreeMaker has to keep track of a few more things now. And something like this. Just CWV names and then use them. Again, okay, so we keep temp this time. Instead using temp2. Just to be sure. Also, have it just a simple AND operator, or is it some weird one? AND. Okay. And see if I can go multi-line. And my constants. Yeah. So if it contains the current component, the set component contains that command, then you can insert the name, otherwise it's unknown. Okay, that should be it. As before, we should just have to change the field type to be string. Otherwise, it would just crash Wireshark. Okay, everything saved. Any errors? Okay, 3 hours. That is good. It looks full. Ping. Unknown. Closed out. Okay, so I would have just to fill out the rest of it to be able to decode all of them, but I'm not going to do this in this video. It would be too much. Just to give an idea how to do this, and I want to continue with the payload. Let's see how far I can get before I run out of time here. So as I said, I created a new file for that, a new packet called TDF, and in here I will create a function to pass a TDF. So I essentially only need a stream for that. definitely want to create a TF resource. For now, let me just make this invalid. Okay, and in my packet handler, I would only keep reading those. So CWV and give it R3. If PDF valid and then we want to break. But for testing purposes, I need to break anyway. If we have a valid TDF, then we will just put this in our payload. What was it in do something table insert? Into payload, we add PDF. Okay, so we have it in the memory, and later we can display it. For now, let's just I don't define the fields yet. Let's actually read them first. TDF, TDF. Do we have any errors so far? Nope. Okay, that's fine. Let's actually pass one then. So yeah, at the very end, I want it to be true. If I return earlier, it will be false. First, I will have to create a tag for it. And that's just an empty string. So if I were to look into here and how these are read, frame, TF decoder, read label, yeah, would be the first thing. And yeah, so reading at TDF is first we read a label, then we read the type, and then we read whatever data is in there. So tag, type, data, and so on. And reading that label is a little bit tricky because they try to save space. So we have 3 bytes and we want to store 4 characters in it. So that would usually, if you have 8-byte characters, need 32 bits, but we only have 24, and so we only use 6 bits per letter essentially, and then bit shift it for 2 bits. So this can be done with stuff like this. If you access just the value as a 24-bit value. Is it so? A 32-bit value? Okay. But I will try, as I can already read single bits. I can just read them one by one. So, oh yeah, for loops, that was fun stuff in Lua. And I have to look at this. Okay. equals 0, 2, 3, 2, and calculating pattern between what's it called, 3 bits. 3 bits. And 6 of them. And then let's hope for the best. And how can I interpret something as a char? String char. Okay. So if c unequals 0, because it can have empty text at the end, then yeah, save this data. And equals take plus this char. Kill data. I want to save this in the list. Take. And we also need access to Blaze here. We can do some debug printing. And let's see what take we get. Okay. Make better text. Flex, PSS, address, data. Yeah, this all makes a lot more sense now. Okay, so we can read the text. That was quite a journey. So, also why is this lowercase? I think everything is uppercase in the other objects. Okay. We don't need to add print stuff. Okay. So now we have the type. It will tell us what type of data to read next. Okay, quick question, does Lua have switch cases? I think not. Okay, it doesn't. Well, isn't that great? What types do we even have? Let's check the original code, or the someone already did the work. Decode VTF. Okay, type. Oh, these are all classes. Oh yeah, the base types. It's probably useful to choose you. Okay, to have these values as strings instead of numbers. But yeah, let's just implement one. Let's take integer. It's probably the easiest one because I have to finish this video. It's already getting long. I'm sorry. So, just for shorthand. And integer is 0. Right. 0. Then else. So if we got this far, we can assume we are able to read this and get a type. And if we know the type, then the result should be true, so we can write the value. Integer is, let's see, value, yeah, it's value decode integer, decode integer. Yeah, this is essentially a packed int. I should write a util for that. But I think I already have written one. Let me check. Read impact. So read data. Yeah, well, that's close to what I want. Until so more is if we have the highest bit set. The actual data. So this what takes the data. Data is outside bits. Oh yeah, we keep track of the bit path. Data can be shifted by just the data will be reread, that doesn't matter, and bit path plus 7. Okay, so we read a byte. We check if the highest bit is set to check out if we have more to read. Do we the value? Oh yeah, this is taking account that it should only be 8 values, so 64-bit in size maximum. Byte 7F and then shift it. -1. Why? Also byte 3F. Okay, this is confusing. I will probably just use this algorithm. Okay, translation time. Then okay. Okay, this should do the same. Let's try it out. For that is and for that is and for that. Okay, let's do. And let's have some debug output to see if we actually get values. Okay. How many errors? 914. Oh yeah. Okay. Finally. Okay. So what do we get? 1, 1, 1, 1. Okay, we get values. What's this, for example? It would be nice to know the text for that. Yes, that makes sense. Makes sense. 1,003. Yeah, that looks like it actually just works. Flags. I mean, it shows it with a comma value, but it doesn't matter. Okay, so now that we have them, let's display them. Just one example one. I mean, there are a lot more types to handle here, but one example, this should be enough. Tree maker, you get a new function. Tree maker, BF Blaze. We need PDF and wait. Because again, this can be nested, so I want to reuse this function later. Yes. Okay. How do I iterate over a list? I guess I can, yeah. Oh, in pairs. No, it's not pairs. What? I guess this has something to do with hashtag operator again. in pairs. That keys. Okay. Okay. What? Number of two image from PDF space PDF file and payload node as a root. Let's see if that syntax is even halfway okay. Okay, so let's define a few fields for that. We have, what do we need? We need something, one script that's just a PDF. Then a PDF tag, which is a string. Then the PDF type. And finally is a data. Which for now I just make a string to output anything. Okay, now let's add these fields. 1, 2, 3, 4. That should be valid. Okay. Also, I should check if the TDF is valid. Okay, also do this here. Yes, okay. Oh, I also need the buffer to tell the range. Let's make it 0, 0. And this should already add some nodes. Wireshark display. Maybe to save space, I can just reduce this to one single field. How about that? So how about we only have TDF? Use of type string. So I want to display the tag, in brackets its type, and then finally the value at the end inside one node. Okay, because again these can be nested and it's probably too over nested to make them nested again. Okay, now the actual value. It would be nice to drop the comma. Or maybe X display. Oh, come on. String format. Yay. Which what I'm looking for. Okay, let's do that again, and now we should be able to read a few of these tags. Okay, let's see. Probably also displays uh, displays a value in decimal as well. $999, okay. Why is that? Okay. BF3. I have the suspicion this was 1,000. Was this rounded or something? Okay, but you can see anyway that it's finally displaying stuff that make hopefully sense. Oh, give me another one. Game ID. Okay. Attributes. Attributes. Oh, yeah, it's 1,000 again. Okay, so maybe that was why I was looking up. Okay, at least these all makes context. These are all these texts are just shorthand for some word. So I don't know, like time or so. That is a word that only has 4 letters, but this would probably be context or so. Let's see what examples do we have. Unknown, is it anonymous? Server time. I don't know. Use ID or something. Flags. So yeah, and probably if there are multiple, I can only let it read them. To not auto break like I did here. See if we have a packet with multiple integers, one after another. So we should see multiple of these now. Yeah, okay. So one after another. And again, some of these have nested data, so there could be another node below it and below it and below it to display it here. Sorry for this video getting so long. I will post the whole working version on GitHub once I'm done with it. I'm not sure if I'll make a part 3 to actually show how I implement all the other types here. But yeah, I hope you learned something today, and thank you for watching, and see you next time.